All right, so you need out your conic formula sheet, the one that has the big chart on it. Next, you need out the document that says 10.4 notes hyperbola. And third, the 10-4 practice worksheet. We're going to do some of those too. All right. Everyone excited for the weekend? Looks like nice weather. Minus Sunday. I think Sunday just looks like rain. Still warm. No, you're right. Still warm, no snow. What else can you? You can't complain. Not in Syracuse, you can't. If you've got extra colors with you today too to do these asymptotes, you might want them. No big deal if you don't. So assignments for this week, and I'll remember to come back to this at the end as well. You have 2 textbook assignments, just those select problems that are listed there. These are posted on Classroom as well. And at the very back of that stapled packet, there's a sheet that says Conics Review. So you're completing those as well. And now, obviously, a lot of these problems take a significant amount of time to get through. So just, watch your time management with those. Again, that one worksheet, that's going to take you a big chunk of time. Same thing with your textbook assignments. And what's going to change next week, because your schedule changes, is you don't need to submit anything electronically to me between now and when you return from class. What I'll do instead is when you come in Wednesday, I'm going to check those 3 assignments. Okay? Answers are posted again already for you, just in case you want to obviously confirm as you go. It's fine if you use those. When you return next Wednesday, we're going to do Conics Review, and then we're moving on to chapter 12, which is your last chapter. Okay? So you have no Delta assignments this week, and no quizzes this week either. Hopefully that's okay. All right, so I am going to first bump over to your formula sheet. All right, all the way over to your formula sheet. And I want you to look at the heading that says hyperbola now. So this is your last conic that we are going to discuss. And I want you to write one thing down just for your reference here too. What's going to change with these hyperbola today is your a squared value. And your a squared value is always going to be located in the denominator of the first fraction. So I want you to write here, I'll keep this consolidated. So I'm going to say a squared is always denominator for the first term. So again, that is different than yesterday. So for a hyperbola, a squared is always the denominator for the first term. For the first term. So big note for you. So here's what these are going to look like today instead. So the first formula is what is known as a horizontal transverse axis instead of a major axis. So this one is going to represent a horizontal, and then again, instead of major, call it transverse axis. And instead of it being the shape of an ellipse, a hyperbola is kind of like a parabola. So this one right here, I'm looking for some space, is going to look like this. So it opens left and right instead. So it's going to open like that. And then my other guy, so this one has a vertical transverse axis. This one is vertical transverse axis, and it's just going to open the other way as well. So vertical transverse axis, and again, opens like this and like this. So when you go to do your vertices, you're only going to have 2 instead of 4 like yesterday. Okay, and just like when you did the parabola directrix questions, your focus is always going to be inside of it. So you'll have one that'll be like right here. So I'll say like focus 1, and then you'd have one that would be like over here somewhere. Same thing, focus, focus, just in case you want some detail to that. Okay. Now, what characterizes a hyperbola and makes it different than an ellipse is that your A and C values are now going to have opposite signs. Okay, so you'll see instead of a plus in the middle, hyperbola's got the minus. So those are going to be opposite. And if you encounter one of these, x times y equals k, all you would do is use your graphing calculator and just whatever k happens to be, you just type this right into the y equals. Okay, we don't really do a lot of those. Actually, I don't think we're going to do any, but it is another type of hyperbola. All right, so you can keep your formula sheet out in front of you and now look over at your 10.4 notes. And again, I already kind of talked to all this information here, so I'll just do a couple little pictures here. So this was your first one. This was your parabola that's going to open left and right. Just like that. This is your parabola here that's going to open up and down. So those two cases here. This right here, make a big star. So a squared is always the denominator for the first term. And again, that's what is different from yesterday, one of the main things. Cross this off. I'm sorry, it got typed in there wrong. What this needs to say for a hyperbola instead is that A and C have opposite signs. So A and C have opposite signs. And then I'm going to give you your two little formulas similar to yesterday too. All right, see if I can squeeze all this. Looking for my space. All right, so you have the transverse axis. So your transverse axis, just like your major axis from yesterday, and this is equal to 2 times A. And then you're going to also see what is referred to, so the opposite one. So instead of saying a minor axis, we say conjugate axis. In your conjugate axis, if you need to find it, is just equal to 2 times B instead. So conjugate axis is equal to 2 times B instead. Everything else is pretty much the same. So you have your distance of A here, center to the vertex, and then C is still going to be your length from your center to your focus. So that's the same. Obviously, you're only going to have the 2 vertices instead of the 4 for this one. And then C is different. So when you go to find your foci, you're going to do C squared equals A squared plus B squared instead. Okay, so yesterday was minus, today's plus. And then the last part that characterizes a hyperbola is you are going to have asymptotes. Okay, and what you're going to do is you are going to use your slope to count rise over run off your center. You're going to use your slope to count up your rise over run off your center point. So here's your formula for when you have the horizontal transverse axis. And again, that's the hyperbola that looks like this. And then here is your formula for your vertical. So vertical looks like this. Okay, they're very similar. All they do is flip the A and the B. And the A and the B are the same A and B that we were referring to yesterday. So same type of thing. All right, so let's jump in and start these because that's all the information that you need. So number 1, find the equation for the hyperbola given. So you have your foci that are given and you have your 2 vertices given. I want you to make a bigger than usual graph for this because I want to fit some details on this. So let's see. I'm going to have you label some things we need. Hopefully that's sufficient. All right, so to start this picture, bless you. So my foci are 4, 0 and -4, 0. I'm going to go 1, 2, 3, 4 zeros my first. And I have -4, 0. I'll call this focus 2, doesn't matter. Focus 1. Okay. Then my vertices are located at 1, 0 and -1, 0. So this means that I have a horizontal transverse axis. Okay, because those are located right on the X. So this is a horizontal transverse axis. You can abbreviate anything you want for the purpose of your notes. I know all these things get kind of lengthy. So now you're going to draw these. So if we have a horizontal transverse axis, that means that these are going to open left and right. So opens left and right. So there's all your detail. All right, so you're going to sketch it like this, and up like this, and like that. Okay. And now what's helpful to do here is let's find the center. I think you probably see where the center is, right at 0, 0. So here's my center. I'm going to state that. So over on the side here, my center is located at 0, 0. We also established that we have a horizontal transverse axis and we have to generate the equation. So it's going to look like this. So it's going to be this one, x minus h squared over a squared minus instead. And then I'm going to go y minus k squared over b squared equal to 1. Which means we need some information from this. Okay, so we need the a and the b. We already have the center, so if you want, you can start plugging that in. So my center would just be 0, 0. So right now I know x squared over something, and I also know y squared over an unknown b value at this point, and then this is equal to 1. Okay, so now you want to use your picture and find your values here. Oh, I still made that too small. So your a value is always your distance from your center to your vertex. Sorry, I know it's hard to kind of squeeze that in here. So this distance from here to here is a, bless you. So a is equal to 1. All right, so I'm going to list that over here on the side. So a is equal to 1, indicating in your formula, you're going to go a squared equals 1. The next value that you're going to find here off your graph is your c value. So from here to here, so center to focus, this is your value of c, and this is equal to 4. So c is equal to 4. Therefore, c squared for our formula, obviously 16. So c is always your distance from your center to your focus. So I'm almost done here. The only thing I need to find is b. So to find b, you're going to pull the formula from your chart. So c squared is equal to, and I have a squared plus b squared instead. All right, so c squared, I'm going to sub in 16. A squared, I'm going to sub in 1. B squared is unknown. You don't need to show any of that. So b squared is equal to 15. And now you can plug in. So your answer is going to be x squared over, where is it, 1? And then y squared over 15 equal to 1. Did it just say equation or did it say asymptotes too? Just equation. Yep, so you're done on this one. Just like that. And again, just be aware that you're going to have a subtraction sign in between these instead. All right, how's the first one, okay? All right, hopefully I had you make that graph big enough so you can kind of see those values. Kind of watching for your spacing. Yeah, this one shouldn't be terrible. All right, so your next one, find the center, vertices, foci, and this one has asymptotes for this equation. So this, if you look at your formula, is the same exact transverse axis as the last question. So this setup here is going to be a horizontal transverse axis again. So you want to start kind of dissecting it and looking for important information. So horizontal transverse axis, again, I'll abbreviate. I can easily pull the center from this. So my center is located at, center is 5, -1. Okay. Now I can also label that 25 represents a squared. And then 9 represents b squared, because remember, a squared is always under the first term. So over here, I'll say a squared equals 25. So indicating a equals plus or minus 5 if you need that, which you probably will. And then b squared is equal to 9. So therefore, b is plus or minus 3 if we need it. All right, let's start putting this together here. So my center is 5, -1. I'm sorry, this graph is small. 1, 2, 3, 4, 5, 1. So there's your center. Now what you need to do is find your 2 vertices. And again, we know that this is horizontal. So just like we did yesterday, and you can do this graphically or you can do it algebraically. It doesn't make any difference. So if you want to do it the same way we did yesterday without necessarily having a graph, for your vertices, you're just going to take your center and you're going to do 5 plus and minus 5. And then you're going to keep your y value the same. So your vertices should be located at 10, -1 and 0, -1. Okay? Or again, if you want to just do it based on your picture, all you do is go over here and you go 5 to the right, 5 to the left. So here and here. Nice to have 2 different options. Those are my vertices. And now because this has a horizontal axis, this means that we are going to open left and right. So opens left and right. So I'm going to sketch it. Kind of looks like this. And other side too. Trying to keep this kind of balanced. That works. All right, so we have the vertices. We need the foci next. Okay, so next part to find your foci. Let me move this down. So I'm going to do the formula again. So to find your foci, we're going to go c squared equals a squared plus b squared. I believe we have those somewhere. A squared we just used here. So a squared is 25, and b squared was right off your equation, so that was 9. So c squared is equal to 34. So therefore, c is equal to plus and minus the square root of 34. And again, what you're going to do is take those values and add them to your transverse axis. So I'll say apply to your transverse axis, which in this case was x. Okay, so we are located here. I'm going to take the center, which was 5. So I'm going to go 5 plus the square root of 34, comma, -1. And then my other, so I'll label this focus 1. And then my other one would be 5 minus the square root of 34 and -1. Focus 2. Again, if you want to plot those, just get your calculator and get a decimal equivalent. They're going to be like somewhere, I don't know, in this vicinity here. I'll just ballpark it. So focus 2, my negative, focus 1. All right, we're not done yet. We're close though. So the last part's the new part. You need to find the equation for your asymptote. So this is on your formula sheet as well, on the top part of your box. And we had a horizontal transverse axis. So for a horizontal transverse axis, your equation for your asymptote, I'm going to abbreviate, is going to be y minus k is equal to plus and minus b divided by a, and then x minus h. Where again, h and k is still just your center. So I am going to go here, y plus 1 is equal to plus and minus, the b value was 3, and the a value was 5. And then you're going to go x minus 5. And then actually you just leave it like that. So here's what we do with this on the graph. You're going to start right at your center, and you're going to use your slope. So 3 over 5, rise over 1. So I'm going to go 1, 2, 3, 1, 2, 3, 4, 5. And then down 3. And then you're going to draw an asymptote. Often these are denoted with dashed lines. You can kind of make them how you want. So these are my asymptotes. And then I got to do the other direction as well, because I do plus and minus. Okay, so there's your first one. Bless you. Now I'm going to go up to the center, and I'm going to go 1, 2, 3, and then 1, 2, 3, 4, 5 this direction. Same thing. 1, 2, 3, 1, 2, 3, 4, and 5. And basically, your hyperbola is just not supposed to hit those. Kind of like that. And you are finally done. I'll put a little note down for your asymptote just in case you want it. So what you do is you start at your center and you use your slope. So start at center. You're going to go up 3 over 5. And then you're going to do the other one. So you're going to go down 3 over 5. So down 3 over 5. Did we get everything? I think we did. Center, vertices, foci, and center. Yeah, you're good. Okay, so again, these do get lengthy. So number 3, do it again. So you need to find the center, the vertices, foci, and equations of the asymptote. So when you're going to look at question number 3, you want to look through it and determine which conic is it. So your choices are circle, parabola, ellipse, or hyperbola. What's this one? Are your signs the same or opposite? Opposite. Yep. So you got hyperbola. On your homework worksheet, these are all mixed up, so you got to be able to decipher that. So your signs are opposite. All right, what do you need to do with a question that looks like this in general form? Completing the square. Okay, so this is the long one. So we've got to do completing the square. All right, so I'm going to take a 4x squared and plus 24x minus the y squared. We have next plus the 4y equal to negative 28. Just like yesterday. So you're going to take out your 4. I'm left with x squared plus 6x. Over to the other side, take out the 1. I've got y squared minus 4y. And then equal to negative 28. And then you're going to complete the square. So this is when we take half. If you don't want to show it, you don't have to. I know these problems are super long already. So half of 6 is 3. 3 squared gives me 9. 9 gets added to the left. And then you got to multiply it by 4 to add it to the right. So I'm going to hop over here. And that gives me negative 28 plus 36. All right, do it again. So I'm going to go minus 1. I've got y squared minus 4y. Again, I'll show it in case you want it. So I'm going to do half of negative 4, which is negative 2. Negative 2 squared is equal to 4. And take that value. And then take that value, negative 4 here. All right, so you're going to factor these. So I have a 4. I get x plus 3 squared. Minus 1. Y minus 2 squared is equal to, and we have 4. 32, yep, 4. Now, just like you did yesterday, this has to be equal to 1. So you're going to take everything and divide by 4. So divide by 4, divide by 4, divide by 4. All right, so I am left with x plus 3 squared over 1 minus y minus 2 squared over 4 is equal to 1. Okay, so let's pull all the important information from this and start getting your vertices, foci, asymptotes. First thing I can immediately state is that my center is going to be located at negative 3 and 2. So negative 3, 2. That's here. Next, I can label that here's my a squared. Here's my b squared. So this indicates that a is equal to plus and minus 1, and that b is equal to plus and minus 2. And the more information you have, the better. This equation, once again, is a horizontal transverse axis. So this one's horizontal. Sorry, those tend to come up more often. So horizontal transverse, but it's no harder to do the other direction. Bless you. So this is going to open left and right. All right, so from here, and again, you can do this algebraically, or if you want, just use the graph. So I'm going to use the a value and go over 1, and then other direction 1 as well. So that's going to be my vertices here. So over 1, and then here too. All right, so it looks kind of like this. And this way. All right, so there's your vertices. Where were those at? Let's see, negative 2, 2. So I'll say vertices. We're at negative 2, 2. And the other one must be negative 4, 2. Yes. So negative 4, 2. Okay, got that. Next thing we need are your foci. And then lastly is your asymptotes. All right, so to find your foci, again, that is your c value. So I'm going to go c squared is equal to a squared plus b squared. So c squared is equal to 1 plus the 4. So c squared is equal to 5. So c is equal to plus and minus the square root of 5. You are going to add this value to your transverse axis, which in this case was still x. All right, so we get, center was -3. So foci number 1 would be at -3 plus the square root of 5, comma 2. And my second would be at -3 minus square root of 5 and 2. Okay, almost done. Again, if you want to plot those, just use your calculator to get your decimal equivalents. But they're going to be somewhere like, you know, around here, give or take. So focus 1, focus 2. All right, that brings us to the last and final part, which is your asymptotes. All right, so I'm going to use this space. So to find your asymptotes, once again, you have a horizontal transverse axis, so your formula is the same. So we're going to go y minus k is equal to plus or minus b over a, x minus h. All right, sub these in. So I have here, I'm looking for my center. Y minus 2 is equal to plus and minus, where's b? So much information at this point. 2, and a was 1, and then this is x plus 3. So you're going to use your slope off your center. So from my center point, I go up 2 over 1. If you want, you can do a couple of them. Just to kind of help you draw it straighter. So here's the first one. And second, just go the other direction. So from this, 1, 2 over 1, 1, 2 over 1, back this way. And there you have it. Finally done. Hyperbola is your longest. Yes, we have everything. Okay, how's that all the way through? Perfect. So I'm going to change gears and again, only do just a couple of these on your other sheet. So I want to start actually, let's start with 3 and 4 quick first and then do 7, 8, and then we'll see what we have time for. If you want to do any more of these for extra practice, again, your answers are posted for your reference if you want them. But up to you. All right, so what did I say, number 3? Yes. Oh, that's not what I want. That's bigger. Yeah, so find the sheet that says 10-4 on the top. All right, so we'll start right with 3. So state whether each one is a circle, ellipse, parabola, or hyperbola. So now when you look at number 3, what's number 3? Look at your A and your C. Are they the same sign or are they opposite? Same sign, yep. So same sign indicates yesterday, ellipse. And if they're completely equal, it's a circle. So same sign, this one's an ellipse now. And then this one over here. So your signs are opposite on your A and C. So this one's a hyperbola. So A and C are opposite signs. So this one would indicate the hyperbola. Okay, 5 and 6 I'm going to skip for the time being, but I want to do 7 and 8. 7 and 8 for sure. All right, so number 7 tells you that the length of the conjugate axis is 6. You wrote down a little formula on your note sheet that conjugate axis is always 2b. So 2b is equal to 6. So this indicates that your b is 3. Next thing I see here is that you have vertices that are -3, 0, and 5, 0. I'm going to find some space to draw a bigger picture. We have -3, 0, 5, 0. So -3, 0, 5, 0. So this axis, once again, is horizontal. Your vertices are right on it. So this means we have a horizontal transverse axis. So your formula, same as before. So we're going to go x minus h squared over a squared minus y minus k squared over b squared equals 1. We already have the b value. You need the center and you need the a. So to find the center, all you have to do is eyeball this, as long as your picture is nice and accurate. Bless you. You're sneezing your head off back there. So we're going to move over this direction here. There's my center. So center is located at 1, 0. So that can get plugged in right now if you want. So this is going to be x minus 1 squared. And then this one's just going to be y squared. And then this is equal to 1. And we already knew that your b squared value was, well, it'll be 9. So last thing you need to find here is going to be your a. So we have here your vertices are equal to -3, 0, 5, 0. So all I have to do is kind of count this. So my hyperbola will look like this. And this direction too. And then here's your a value. So from here to here, center to vertex is always a. And what's that equal to? 4, yep. So just count. Again, you can do a lot of these algebraically, but it's like if you're willing to draw a picture, you can just count it out. So I've got 16. Okay, so that would be your final solution. I'll list this over here. So a was equal to 4. All you do is count off your graph. So count from center to vertex. Either direction doesn't make any difference. Okay, and last, because I need to give you one that goes this direction finally, just so you understand it's no harder. So number 8, you have vertices located at 2, 1, and 2, 7. Focus is at 2, 8. So another picture. All right, so I have 2, 1 and 2, 7. 2, 3, 7, and I need 8. So this time, what kind of axis do you have? Because those are your vertices. So we have a vertical. So I'm going to sketch these in here. So we're going to go just like this. Opens up and down. Opens up and down. And you're going to go right in the center of this to get your center. So my center is located at We've got 2 comma, that's 6 units, so up 3 would give me 2, 4. Next thing you're going to need is most likely this A value. So right there. So from my vertex up to my center here, I can say that A is equal to 3. I also need to plot on here that my focus is located at 2, 8. See if I can fit that in there too. So focus is 2, 8. So that's here. Focus, which means that this one would be right here. Same distance again. Here's another focus. And what that means that you can find right now is your C value. So remember that your C value is your distance from your focus to your center. That's here. So I'm going to say C is equal to 4. All right, so now all we do is plug all this stuff in. So I have my equation here is going to be instead. I have, let's see, how did we start? Nope, same thing. So you're going to go x minus h squared over a squared. And then you're going to go minus, and we're going to go, no, it flipped, didn't it? Gotta flip my order, sorry. Just gotta flip this. All right, so I'm going to go y minus k squared over a squared minus, and I'm going to go x minus h squared over b squared equal to 1. Okay, so our center point is at 2, 4, so I'm going to have y minus 4 squared over a squared. Did we have that somewhere? Yes, so here's 3. Yep, so you're going to go 9. Minus x minus 2 squared b squared. I think we have to find, and this is equal to 1. All right, so last but not least here, to find my b value. So I'm going to go c squared equals a squared plus b squared. And your c squared was 16. A squared was 9. B squared was unknown. So b squared is equal to 7. And done. All right, so that's how you're going to do one that has a vertical transverse axis instead. Essentially the same thing. Just have to be careful, plug into the correct formula. All right, how do we feel on all of those? Okay, so your assignments again, because then I'll let you start and kind of work. I think you've got what you need. You just need to kind of practice it. So again, for your assignments, you've got textbook homework to complete. You can just do those on paper like you usually do. And then your review sheet is the one in your packet that looks just like this. Okay, these are all mixed up just so you're aware. And if you want extra paper, because I struggle to fit everything in here, feel free to use extra paper and do graphs as well. Because sometimes the graphs are helpful, so do them if you need to. But just be aware that this sheet is going to take you some, substantial amount of time to get through. All 3 assignments I will check when you return to class next Wednesday. And if you have questions, that's a great opportunity for you to ask, because all we're doing next Wednesday is review of that unit. Okay? Questions, guys? Okay. Yep, get started on something, please.